Hi everyone, my name is Jonathan Pilot, and this is the Emarketing Campaign project. There are two parts to this project. The first part is a simple decision tree, and the second part is getting a dollar amount on the value of imperfect information. In the first part, we are constructing an e-marketing campaign for a random set of users. And just to give you a little bit of background, if somebody clicks on an ad, there's a 1 to 5% chance that they would convert or buy something. So that's, to be on the safe side, I use 1%. In this particular case, we should not launch the email marketing campaign. So now let's see what happens if we have a little bit more data, if we know a little bit more about the user, and to a certain level of accuracy, we can model their behavior. So this is my dynamic tree. And I'm saying dynamic because, as you can see here, it's not 1%, it's 17%, and that's because it's linked to the accuracy of data. So if you looked at this cell here, I'm going to find when it's starting to become interesting for us to run the e-marketing campaign. So between 45 and 46% accuracy of data, it becomes interesting to launch an e-marketing campaign. And that's when there's a probability of 6% that users buy online. So with this tree, I flipped it, and I have a dynamic flip tree. That means it's dependent on the assumptions here, but also on the accuracy of data here. And I've calculated the value of imperfect information. And how I calculated this, I compared the flip tree with the old tree, and I did flip tree minus old tree. I wanted to know what's the value of knowing beforehand who's going to be interested in my product to a certain level of accuracy versus randomly sending the marketing to users. So here I did a little bit of sensitivity analysis, and that's the graph of the sensitivity analysis. Let me give you a little bit more more concrete example. Let's just say I'm Google and I'm targeting super users. So that means people who have all sorts of apps with Google, who have the Android phone, who give away a lot of data to Google through Gmail, Google Plus, YouTube, etc. So if I target super users, there's a 75% chance or 75% accuracy in modeling their behavior. If I compare the old tree and the flip tree, that gives me a value of imperfect information of $3,400. So what that means is that per user, their information is worth $3.40. And this is just, I think I'm going to start using this as a tool next time I download an app or give away all sorts of information, because it gives me a little bit of insight on how much that app is worth. So that's about it. Thank you for listening, and have a good day.